Okay, so this is part 3 of our fundamental trig identities lesson. Um, I got cut off on the last video. We were looking at how to find the tangent of u given that the secant of u was -3/2 and the tangent was positive. And so I left off here with the tangent of u equals -√5 over -2. After you simplify this fraction, remember you're going to flip the bottom fraction and multiply, and the 3's cancel out. You get -√5 over -2, which simplifies to √5 over 2. The cotangent is simply the reciprocal of that, but then after you rationalize 2 divided by the square root of 5, you get 2 square roots of 5 over 5. And that problem is done. Okay, so the next topic that we're going to be looking at is using identities to simplify trig expressions. So at first, this is really, it can be kind of overwhelming because it's going to seem like there's just so many different routes that you could go. But really, after some practice, it starts to become a lot easier. You'll start to recognize what to do when. And sometimes you'll end up going in the wrong direction, and that's okay, because you'll figure that out as you're going and go, oh, maybe that's not what I should be doing. I should be trying something different. And that's just going to take practice. It's as simple as that. So here's an example. Simplify sine of x minus sine cubed x. There's nothing wrong with this expression, but it has equivalent expressions, and that's what I want you to be able to recognize, that you can rewrite expressions in different forms. So when you are doing a problem, a lot of times I'm going to tell you what I want you to simplify this to, so you'll know what the end result has to be, and you just have to get there. Okay, for this example right here, in this example 2, you have sine of x minus sine cubed x, and what I want to do is, looking at this, I have a sine of x in both of those terms right there. Remember that if you look at sine, it's not letting me grab this pen. Come on. Okay. Well, I'll just have to do this with a thicker pen, I guess. It's not letting me grab that. On the page, sine of x minus sine cubed x. Remember that this can be written as sine of x, that quantity, cubed. When the cube is between the sine and the x, that's what that means. So I have a sine of x common to both of these terms. So that's one thing you're going to be looking for. Do you have something common to all the terms? And if so, then you can factor that term, that common term out. So I'm going to pull out a sine of x, and what would be left inside the parentheses, I'm factoring out the sine of x, I have a 1 minus sine squared x left inside the parentheses. And if you think about it, if you distributed sine of x back through here again, we would get what we started with. But I don't want to do that because I'm trying to rewrite this in a different, in like a simplified form. So now what you need to start looking for, and this is it will take a little bit of time to start like seeing it, but right here we have a sine squared x. And what I want you to be thinking about is, oh yeah, there's an identity that involves sine squared x. Recall this identity here. You had sine squared x plus cosine squared x equals 1. Now, this is one form of this identity, but we can rearrange this however we want to, and it'll still be an identity. If I subtract sine squared x from both sides of this equation, on the left side I have cosine squared x, since these cancel, the signs cancel out. Oops. Equals 1 minus sine squared x. So, rearranging this identity, I have 1 minus sine squared x, which is exactly what I have right here. And this cosine squared x is the same thing, because it's an identity, as 1 minus sine squared x. So I can replace this right here with cosine squared x. And that is as far as we're going to go with this one. And so I might tell you to simplify this expression to a single term or something like that, so you know what you're aiming for here. Okay, so let's look at one other example. Let's do the second one here. We're going to simplify cosine of x over 1 minus sine of x minus sine of x over cosine of x. So, I'll pull that down. In this case, there's no common term. This is a term, and this is a term, and there's nothing common to both of those terms. I mean, you have a cosine of x in both terms, but it's not common. It's in the numerator on one side and in the denominator on the other side. So what you want to do in this case, instead of factoring out common terms, when you see a denominator, another method that you're going to be looking to use is finding a common denominator and combining these terms into one. So my common denominator, my least common denominator, would be this 1 minus sine of x times, the other side has cosine of x. So that's part of my, this would be my least common denominator right here. So on the left side, I'm going to need to multiply the top and bottom by cosine of x, which is really multiplying by 1. And then on the right side here, I have to multiply by, what's missing from the denominator is this 1 minus sine of x. So I'm going to multiply that on the top and on the bottom. Make sure you put it in parentheses. And now I have a least common denominator. And so what I'm going to do is, oops, I forgot the parentheses there after I just said that. Okay, so I'm going to simplify this. So I have cosine of x times cosine of x, which is cosine squared x. I wish this button, this will not let me get to the thinner pen. Over cosine of x times 1 minus sine of x. And then over here, if I distribute the sine of x, this is subtracting this whole numerator over here, minus sine of x, and then minus sine squared x, and that's over this denominator. Even though the denominators are written switched, the two factors are switched, it's still a common denominator. So now I can take this numerator, cosine squared x, minus, I'm going to distribute this negative through, minus sine of x, and then plus sine squared x, and that's all over. I'm running into example 4 here. This big pen is not making that very easy. Over cosine of x times 1 minus sine x. Now look in the top, in the numerator, do you see an identity of any kind? Hopefully you do. We have a cosine squared x, we have a sine squared x. If I rearrange that, I get sine squared x, and I can do that by the commutative property, plus cosine squared x, and then I still have minus sine of x. And it's over cosine of x times 1 minus sine of x. What is sine squared x plus cosine squared x equal to? Do you remember? It is equal to 1. So here, this is 1 minus sine of x, and then that's divided by cosine of x times 1 minus sine of x. These two cancel out, and you're left with 1 over cosine of x, which is equal to secant of x. That is the simplified version. For when you have fractions, be looking for that common denominator.